Good day, everybody. Welcome to Chapter 15, Part 1. This is Generating Data, and I'm here with my navigator, Ethan.
Hello.
So we were given the try for cells from 15.1 to 15.3. So I'm going to do my best to explain this. I've obviously made notes to help me, but this is data analytics. So for our first one, basically we're making graphs and stuff. So anything from your simplest bar graph to trigonometry graphs. I think it's called a sin graph or something. So in our first one, we have a generating the first. Maybe I should actually just read the thing or just show it on screen for context. Okay, so here we're making a number raised to the third power is a cube. Plot the first 5 cubic numbers and then plot the first 5,000 cubic numbers. So here's the first 5 that we have plotted. That's our x values. And then to the power of 3, it will be our y values. So let me just open this up. So here's our first 5 cubic numbers graph. You can see it goes all the way up to 5. So basically what this does here is that it's just plotting them. We've got our labels on the side. So it's literally just math, but on a computer. Everything generated via code. So there's your heading of your graph, the cubic numbers on the side, and then your numbers on the bottom. Everything is labeled as it should be. You obviously insert all of that here, and then you plot it to show and stuff. If I close this, it's going to show us the first 5,000 cubic numbers. As you can see here, it's the x values have generated lists from 1 to 5,001. Because if it's 1 to 5,000, it would only be 1 to 5 to 4,999. So that's what that looks like. Again, it's the same as the first one, just the numbers have increased. And then in 5.2, we have color mapping. So this is cubes with a color map. This is basically just making your graph look pretty. So again, it's basically the same one as before, except your line has changed to like a rainbow multicolor. Same as this. So you've got your cube values here, and that's just in color. So this just makes it look nice. And then for 15.3, this is generating a random walk. Let me go fetch it from here. So this is molecular motion. I'm not even going to try to butcher that word. Anyway, this is a scatter map or something like that. So it's basically it's to simulate the path of a pollen grain on the surface of a drop of water. So yeah, it's kind of complicated, but anyway, it's there. So your start is here and your end is here. So we're using the random walk function. So it's 5,000 steps instead of 50,000 steps, basically. It's a pretty long method, but yeah. So it's just a scatter map. Yeah, and obviously you can change the color of this too and stuff. Basically, what we did in color map in 15.2. So moving on. Oh well, that was the same one. Anyway, it's basically that was making the method also shorter. Yeah, so we're expanding the distances as well, and it's only the forward movements, as you saw. Yeah, that's pretty much it. It was just all that, and it kind of links back to 15.3. It's just to shorten up the scatter map itself and stuff. So yeah, thank you.